Okay, I send you a link. I just dropped the link in the Discord.
Okay, let me see.
Okay, can you see CoderPad?
Yeah, I can.
Okay, is it like fucked up? Is it all right?
Wait, I'll take. I'll drop him the call first and try to listen.
Okay. Um. Okay. Saf, I'm gonna send you a CoderPad.
Yeah, sure.
Okay, you join the CoderPad now.
It works well.
Okay.
I
Can you
everything's okay. Yeah.
can you hear Saf? Like,
Yeah,
Wait,
I can hear you.
wait.
sorry.
Let
I
me.
mean, Kevin, can you hear his voice?
Yeah, I can hear you.
Uh.
Yeah, yeah. Actually, I heard my voice. Yeah, I can hear myself too, so it's fine. Yeah,
Okay. Awesome.
yeah. Okay.
Okay. Thank you.
See ya. Bye
See
bye.
ya.
Have fun.
Bye.
Good luck.
Okay. Okay.
Give
So
me a second.
wait. Sorry.
Give me a second. Let me join the coder pad.
Okay. Yeah.
Yeah. Okay. Okay. Yeah, I think I'm there. Can you see me?
Not yet. Oh, okay. Now I can see you. Okay, we're
Yeah.
live by the way, but don't feel stressed or anything. Like, just don't. Um, just pretend people are not there.
Yeah.
Okay. Are you ready to start?
Give me a second.
Okay.
Yeah. Okay.
Okay. So
Uh,
yes, all good.
yeah, I'm ready. Yeah.
Okay. So welcome to today's mock interview. Um, you're going to be coding in Python, correct? And this is going to be a hard problem.
Yeah.
Okay. Amazing. Here now I'm going to paste the problem statement into the chat and you can take your time to read it. Okay, so that's the
Right.
problem statement, and now I'm going to paste the code stub as well.
Okay. So I'll just start reading it.
Yeah, for sure.
That's everything, right?
Yeah, it's everything.
Okay. Bounded blocking queues are a key abstraction in concurrent implemented a thread-safe bounded blocking queue that has following methods. So just to be clear, what does thread-safe mean? Does it mean that if two elements are two threads are accessing the queue together, uh, like uh, like it shouldn't cause race conditions, something like that.
Yeah, yeah,
Maybe
yeah,
you can
exactly.
clarify what does. Yeah. Okay.
Well, I think you can continue reading the whole problem first, then it might answer your question.
Yeah. Okay. The constructor initializes the queue with a maximum capacity. Okay. And then in queue, we need to add an element in front of the queue. If the queue is full, the calling thread is blocked until the queue is no longer full. And then dequeue returns the element at the back of the queue and removes it. If the queue is empty, the calling thread until the queue is no longer empty. Size returns the number of elements in the queue. You'll be tested using multiple threads at the same time. Each thread will either be a producer thread that only makes calls to the enqueue method, or a consumer thread that only makes. So a thread cannot may one thread cannot be a producer and a consumer.
Yeah,
It would be either a producer or a consumer. Okay,
yeah,
and then by this maximum capacity, uh, does it so just to clarify, like the function of enqueue,
mm-hmm,
let's say I have two threads accessing the enqueue, two threads putting the element in the front. I need to make sure that uh, once the first one puts, like when both call together,
mm-hmm.
uh, the queue should be modified safely, right?
Yeah,
That's what it means by thread safe, right? Okay. And if by the time we have reached the capacity, the queue which is trying to add over the capacity has to be blocked,
yeah,
Now, now what if we have like multiple queues blocked together? Uh, do we need to like insert them in the order once the queue starts freeing up, or what do we need to do in that case? So let's say a lot of elements are calling in queue, in queue, in queue, in queue, and like a lot of them are waiting. And let's say some DQs are called and it starts freeing up. The waiting elements, how do we in queue them?
Um, could you like okay? So you're saying that there are multiple producers that
Yeah,
are trying to that are blocked,
in queue.
and
Yeah,
then
yeah,
once the queue once the queue is dequeued and there's like space, like you're asking like how do we like prioritize what which thread
yeah,
gets to put in.
yeah.
It should just be um, the thread that requested it first.
Okay, okay. And then turns the element at the rear of the queue and removes it if the queue is empty, the calling thread is blocked. And the element is the producer and consumer, they're always trying to push an integer element. Is that assumed, or they can like push something else and we need
Yeah,
to make
always
sure that.
integer, always integer.
Okay, okay. So this size includes the elements in the queue. Does it also includes the elements that are blocking, the queues that are blocked?
Does it? Uh,
Yeah. So
no. It just
no.
returns whatever is in the bounded blocking queue.
Yeah. So it's kind of capped at C,
Yeah,
basically the
it is
capacity.
capped at
Yeah.
capacity. Correct.
Yeah. Okay. Um, so there are two things I'm thinking of straight away. Do you have any sample test cases, or like maybe I can like maybe have
Why
a
don't you go
picture?
ahead and like create some, and I can like comment on whether they are correct or not.
Yeah. So maybe let's start with having a capacity of two, um,
Okay.
and we have a queue. First, we have a producer that maybe asks us to enqueue the element three. So in that case, we'll just put in three at the front, yeah. Uh, and since this is under the capacity, it's fine. Um, Again, a producer calls five.
Mm-hmm.
We add five here, and obviously size is two. Then another producer calls six, and then we have another producer calls seven. So this six and seven, since our queue is right now at two, we kind of have to, we need to like, keep these six and sevens waiting. Then let's say we have a consumer that tries to get that calls DQ.
Mm-hmm.
So then we return the element from the rear of the queue. So it means that five will be gone, right? So if
Yes,
a
yes.
consumer,
It's a deck. Yes.
yeah, so it five. So once five is gone, we realize the capacity is now one, the size is now one. So since size is less than the capacity,
Wait.
we have to put in.
Sorry. We we append elements to the front of the queue. So five will be here, and so three will be gone actually.
Okay, yeah. My bad. Yeah. So three will be
Sorry,
gone.
my
Yeah,
bad too.
yeah. It's a queue.
Mm-hmm.
And then we just at this once we dequeue, we immediately realize that, oh, we have some capacity. Let's look at the elements that are waiting. So six and seven were waiting, and we realized that six, since you said that order of like the way they came in, so we decide to queue in six,
Mm-hmm.
and six will be queued at front, making the same mistake again.
Yeah.
uh, and now here this capacity is far like same, back to C.
Mm-hmm.
That's simply the mechanism I'm thinking of, and straight away I think first thing we need to ensure is if we are blocking elements, we need to keep track of them. So we might be needing two queues here. One of them would be to track the actual queue. The other one and that queue would be of size C at max. The other queue could be of any size, which would essentially track the elements that are blocking, right? Uh, so like just like going back this example, we would have five here, three here, and here we would have seven here and six here. So this is our waiting queue, and this is our actual queue,
Okay.
right? Uh, so do you think like having two queues is a correct approach?
Not really, because like the thread
Mm.
is not blocked.
Sh- Oh, yeah, the safe access part. Hmm. So
It doesn't really like um yeah make it thread safe.
oh yeah, do we need to use then something like locks or
Yes.
something?
Yes.
Yeah, yeah, okay. So it means like once the capacity is like at C, we don't release the lock, we just keep on holding the lock.
Sorry, could you repeat that?
Uh, so once we like up in queue 3 and 5, we realize that it has reached the capacity, and once we have reached the capacity, we hold the lock for our queue. We don't release it for elements that are waiting. Is that what you mean by using a lock?
Um, I can't really like tell you how to implement this, but
Yeah, okay,
I can
okay.
definitely say that locks are needed.
Yeah,
You're on
yeah,
the
so
correct
so
path in that case.
so what I'm thinking is that uh, we might want to have a lock for this queue of our element, and once an element tries to enqueue, it tries to get hold of the lock first, right? And we
Mm-hmm.
will uh, we will we will decide to give the lock by checking if our size is less than capacity or not. If the size is
Okay.
less than the capacity, it means we have space and the element can properly like safely enqueue it. So once we hold the lock, once we give the lock to the element, it can finally enqueue. But let's say our size is equal to the capacity, then we don't give the lock, and the element would be, I would assume, like like since we are working with locks, the element would be a blocking thread.
Yeah. Yeah.
Yeah,
That is a
yeah.
correct train of thought. Yeah.
Yeah, and with DQ, I would say that first thing with and another thing with NQ that we need to think about is once we are trying to NQ, it could be potentially that someone else has the lock. So I guess that would be automatically done if you are working with the locks. With DQ again, the element will try to get the lock. If it gets the lock, then it will try to safely remove the element from the queue. As soon as it does that, um, as soon as it does that, the producer will have its element. But I guess after it, we need to release the lock to any of the blocking threads. So in DQ, uh,
Mm-hmm.
uh, we need to also, after dequeuing uh, after dequeuing we need to uh, make sure uh, uh, that the lock is released for any other enqueues. That's my thought process.
Yeah.
So it means that we need to have a queue in our class and a lock and a lock as a field, uh, aside from the size and capacity. Um, Obviously, like while we are enqueuing and dequeuing, we will also manage the size as well. So maybe I think I have gotten a correct idea for like the initialization phase. So maybe I can start putting in the fields if
Uh,
you're fine with that.
okay, I think maybe we could like step back and try to take a look at these ideas first. Um,
Yeah, sure.
okay, so you're saying that when we want to dequeue, we have to like release the lock for the NQs, right?
Yeah.
Okay, so what are we going to do when we want to NQ something? What is going to be contents of NQ over here?
Uh, so here in NQ we would um, first check if the lock is free or not. Maybe I can write it here. So first we'll check lock is free. If the lock is won't free, it would be just blocking call. But let's say the lock is free, uh, then you would, and this is determined by size versus capacity. So um, if the lock is free, so we have some capacity, we hold the lock. And I guess one thing is that how is the lock represented? Is it a Boolean or is it a special built-in something like a mutex? I don't know if Python has something like that. Like
Yeah,
Python should have it. I don't know which
Python
one. Which one is it?
does have locks. Like do you know what type of lock should we use here?
I think it should be a mutex lock.
Why do you think it should be a mutex?
Because we want to ensure that only one producer or slash consumer has the access to the queue all
Yeah,
the time, since
but
we need to
that's the property of all locks. What other why should we choose mutex over like the other options?
um, mm, hmm, I honestly like I why should we have um oh, it I guess with mutex is as soon as the lock is released, the thread automatically continues instead of sleeps, instead of waiting, instead of busy waiting. So maybe
Okay.
that's
Yeah, I agree that
yeah.
using a mutex here is definitely like a lot better than busy waiting. However, um, other than a mutex, what can we use here? Is there something that is better?
Is that something that is better? Let me think about it. So our goal is to have thread access other than mutex. Maybe a conditional what do we call it? Um, yeah, I I can't think of anything that is better. Like in my mind, I was comparing busy waiting with mutexes, but I can't think of any third way of doing it.
Mm, maybe
Hmm.
we could try using like semaphores over here. Could you think
Uh,
of maybe why semaphores will be better than mutexes in this situation?
well, semaphores will give you a count of how many queues are waiting. In that
Yeah,
sense, yeah, it's much easier for it to keep track of how many things that are waiting for it. With mutex, you don't know how many variables are waiting. Uh, so that is one of the reasons that uh, yeah, and I guess Python does have a semaphore class.
yeah,
So what you're saying is that the capacity of I don't exactly know how semaphore works. I think you need to declare it with the capacity, and I guess we declare it with the capacity C.
yeah,
Um,
yeah. We can assume that.
and then uh, obviously once it will hit zero, it would automatically like manage the size itself. We don't need to manage it. Mhm. Uh, so I don't know which class of which what is the Cephomore built-in class or library in Python? Can you tell me which one is it?
Um, you can sort of like use any interface that would make sense to you. Why don't you come up with one that you feel makes sense to you?
Maybe we uh, so so do we so it means that we need to create our own something like a counter like that is essentially a Cephomore. We can create our own class
Oh no.
that
Like you can pick any API that makes sense to you. Like what you said just now makes sense to me. Like the semaphore takes a constructor, which is the capacity.
yeah um hmm, uh oh hmm Cephomore I don't know how to initiate how to which what's it's called though.
Oh, I
Yeah.
mean like you don't have to use like a real interface. Just make up your own interface.
Oh yeah. Okay. Yeah. Okay. Yeah. I think I can do that.
Yeah,
Uh,
yeah, and you don't have to implement it.
yeah. Okay.
Um,
Okay. So so
it's like
maybe
it's
we will.
like semaphore. Maybe
Yeah.
it can be like
Semaphore.
class semaphore. Oh my god, I can't spell.
And then it has some object and then it has a capacity. It should have a capacity where um
Yeah, and then we can do like
yeah something like this. Yeah.
yeah.
And here we
And what
need
other what
here we
other
initialize.
methods do you think it should have?
Uh, Aside from the capacity, it should have if our uh, first of all it should have what data structure it's associated with it. So since it's associated with a queue, maybe it should have a reference to that. Uh, Another thing it should have is it should has is the uh, is it like is the capacity available, so something like a method which can tell that the queue has access to it. So so maybe something like something like maybe has capacity
Why
that
why are
basically
you
just
putting a double underscore here?
yeah okay yeah. Something like have capacity where you can where you don't you just need self and then uh, and then it should return a boolean which tells that there is capacity and you can proceed ahead. uh, if it doesn't it um, it basically says that uh, it basically holds that variable, holds the element that is calling it, and then as soon as the capacity is released, so it lets go of that element. Well, it shouldn't be in the one functionality. This one is just returns a boolean that tells that there is space. The
Um,
other one,
okay. Will this be called by other classes, or is this like an internal method?
so this will be called by other classes.
Why would they want to call it though?
I guess this can be managed internally if we have this entire management inside itself. So if we can find a way of passing in the like the object we are trying to insert, like if it has all the elements, it can do self management. So I mean, this kind of abstracts the for the queues, for the other queues, this kind of abstracts the implementation for them. So they just need to declare a Cephomore and work with it.
But
Uh,
but that doesn't really align with how like locks are typically
yeah,
used, right? Basically, other
yeah,
threads try to acquire the lock, right? And then they
yeah.
release the lock. So I'm not sure if they need like this particular method. They don't need to know.
Hmm.
They don't need to know how much capacity a lock has, unless like I'm missing something.
You're right. Yeah, they just need to know that whether they have to wait or not.
Yeah, they just need to know if they can get the lock or they need to wait for the lock, if that makes sense.
So this should be more like lock available, like something like that. But what I'm wondering is that even if we have a method like lock available, will the should we have other uh, should we have threads calling, should we allow the threads calling in some a method like has lock, uh,
Has lock?
hmm, yeah, something like that tells them that there is lock or not.
Ooh, I don't think the thread needs to know that much or would want to
Yeah.
want to know that much. It just needs to know as little things as possible, if that makes sense. Like when we were like designing this semaphore class, uh, we just want to make it as simple as possible in this case. Like it's just enough for our bounded blocking queue. Like it may have some other functionalities, but we just want to, maybe we could just target to just have expose enough methods to solve this problem.
Huh. I oh yeah, okay. So it means like we need to I need to find out the methods that a sophomore
Oh yeah,
should
yeah, yeah,
yeah, yes, that should be that would be like that could be used only useful to the bounded blocking queue.
yeah.
Let me think of it. I guess I guess it would be like take lock, some a method like that. So give lock, uh,
Mm-hmm.
hmm, and then another method could be release lock. Uh, yeah, these two are the only useful methods that I can think of are relevant to our queue.
Which two?
So something like a release lock and acquire lock.
Yes, yes.
Yeah. So 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 acquire lock,
We can just
acquire
call it
lock.
acquire. We can just call it acquire.
Yeah, acquire, and another one would be release. And
Okay.
pass. And I guess this acquire will only give the lock if if we have some capacity and it knows what capacity we have. Uh,
Yeah, we don't need to. For this interview question, let's not worry about how the semaphore works.
okay, okay,
We can
okay.
go
So
back
we
to
can
our
assume
bounded
that
blocking queue.
yeah, okay. So this means that since we our Cephomore has working here, we can just basically initialize that Cephomore here in our constructor in our queue. Uh, and then in queue method we try to acquire using that Cephomore class. We try to acquire. We try to call this method acquire,
Mm-hmm.
and since we have assumed that implementation is done correctly, it will only give acquire if it's within our capacity. Uh, and once we have that acquire, we will also have a queue, the actual queue object here. So something like a queue. I'll just write it now for now, nothing specific. But like something that basically that will basically take this queue and append it, and then once the append is done safely, we will release the lock. So that's what I think will be done for enqueue. So first we call acquire, uh, we we append to the queue, we increment the size, and we release the lock. We call release. And here in initialization, we would initialize size, Cephomore with capacity C, and then and then uh, and then a queue, right? Uh, so that's what I think for NQ. What do you think about it?
Okay, I realized I forgot to ask one question to you. Uh,
Hmm.
Apologies. Can you please explain to me what a semaphore is and how it differs from a mutex?
So so I think so. So semaphore, what it does, it has a counter,
Okay.
and inside that counter, it kind of keeps track of track of objects that are trying to access the element
Okay.
one at a time. Um, so the way we have designed our semaphore is that it basically, once its capacity, it basically follows the capacity of the queue, right? So
Mm-hmm.
uh, so what it does is that once we acquire something, it will decrease its capacity. But once we try to, well no, that can't work, because the cap capacity is different from what we have in the queue. So we need to also, in our semaphore, we need to track of how many elements,
Yes, that's right.
yeah, how many elements we are
This
working with.
current approach that you suggested won't work.
Yeah, yeah. So basically, we need to also have, well, here it will be initialized with 0, but here we will keep track of elements inside, right? So now, since we are keeping the track of elements inside, it will only give locks till our capacity reaches C. Uh, if our capacity is C, it will stop. Once you call acquire methods, it won't give the locks. Uh, it would essentially like have some busy waiting, or some kind of a way, like a signal or something, to wait. And as soon as we have a DQ call, we will also uh, we will also uh, keep reduce the track of element here, to ensure like the to ensure that, well, now this will be complicated, because here, if we will call acquire here and acquire here, how do we know that if it's enqueue calling an acquire or a dequeue calling an acquire?
Mm-hmm.
So yeah, so now I realize that it's a bit impossible to manage like using this method to manage the capacity. Hmm. Hmm. Mm, yeah, and just need to think something, a different configuration. So this means that capacity management still needs to be done by the bounded blocking queue. Cephomore just needs to manage the lock. Hmm. Oh, this is hard. Right. Yeah, I'm just wondering that. Um, yeah, yeah, yeah. The current approach won't work, because if we call acquire here and release here, it doesn't know whether to increment its count or decrement its count, right? Because acquire call or release call from either of these methods, it can't differentiate, right? So this is tricky. Maybe in acquire, uh, we can also pass another argument that tells that are we incrementing the count or decrementing, something like that. Are we is our purpose to increment the count or decrement the count? That's one way of solving this problem. The other way would be to manage the capacity inside of the queue, and this the Cephamore's job. Then the Cephomore will essentially be won't be of any use. Then we are basically using a mutex, like just to give and release a lock. Hmm. Yeah. So I'm just wondering, like, should we go with the approach of like just using a mutex, or telling Cephomore that are we incrementing our count in the queue, or are we decrementing the count in our queue? So I'm just wondering, like, which one would be a better way.
I think that there's a better way that is neither of those ways. Like,
There is.
definitely the semaphore should not know like anything about what we are doing. So
Okay.
that one's out. I don't really understand how a mutex could fix this problem, to be honest.
Yes, yeah. I guess semaphore can only keep the track of elements that are waiting. It doesn't need to keep the track of capacity. Uh, we can keep the track of capacity here.
But um,
There is a better way.
I
Hmm.
I think that the property of semaphores makes it like very suitable to be like aware of the capacity, if that makes sense.
Okay, the property of semaphore makes it aware of the capacity. Uh, Aware of the capacity. How will it? Oh wow.
Maybe
Yeah.
you could think about
Let
like
me.
how does like a sequence of NQs and DQs, like what do we need when we are like NQing and also DQing? Like take note that we can also DQ here. If in this problem we can only NQ, it'll be easy,
Yeah,
right?
yeah,
But we can
yeah.
also DQ. So DQ also like affects the semaphore in a certain way.
Yeah, yeah, and that's why, like, I am that's the reason I realized, like, the current way of doing it, like the at least like the way I was thinking is not right. So what does DQ do? It it acquires a lock. It Once it acquires the lock, it removes the element, and then immediately, if there is a thread waiting for it, it adds it. Well, then technically means that uh, it doesn't need to keep a track of capacity, because if there is a if there is someone waiting for it, then as soon as we release it, the wait no Hmm, yeah, I am definitely a bit confused here what to do. um DQ, let me think of what are the properties of semaphore. I think my understanding of the properties is wrong here.
Okay, we can talk about that.
uh, yeah. uh So if we initialize a semaphore with a capacity Q, and it keeps track of the NQs and DQs it's calling, how can it know the the counter will be zero, and no.
Okay, I think just in the interest of time, I'm going to like paste the Python API for semaphore in comments over here. Can you see it?
Yeah, yeah. uh so A semaphore manages an atomic counter. Yeah, yeah. Oh yeah, atomic counter representing the number of release calls minus the number of acquire calls plus an initial value. So initial value will be our capacity in this
Mm-hmm.
case, and the number of release calls minus the number of plus an initial value. Okay, so if there are more acquires than release, then it means that our capacity will start reducing, and that's how it will know when to release. Uh, is th- like if there is space or not, and then release means that uh, the acquire method blocks if necessary until it can return without making the counter okay, yeah, so we can't make the counter negative.
Mm-hmm.
Yeah, yeah, I think okay, yeah, okay, I get it. So if we initialize it with capacity, essentially because of we are using this, it uses the calls minus the number of acquiring. It can it will never return if you are it will never release a lock if you are going out of capacity. It will never give a lock if you're going out of capacity, if I'm understanding it correctly.
Yep.
Yeah, so I guess then we can move on to here where we can basically I guess then this approach is right. So first, we don't need to check if the lock is free. We just try to acquire. Here we will initialize the Cephomore as I said. Um, Here we try to acquire it, append it to the queue, increment the size, and then release the lock. Same would be for DQ. Uh, we would just
Which
try to
which
acquire.
lock which semaphore would we release here? We release the same semaphore.
Um, yeah, we call release on the same semaphore.
Doesn't that
If
mean
I,
that this semaphore would always just stay as the initial value then? Because we acquire and then we release.
hmm,
Then what's the point of using a semaphore and initializing with a certain capacity if we are just
so
releasing it right
so
away?
so so we need to release it with a different capacity. We
Well,
need
what do you
to
mean
we need
release it with a different capacity?
no wait. So so what you're so if I rephrase your question, you're asking if we should release the same semaphore or not.
No, I'm
Uh,
asking if why are we releasing it here? Why are we releasing it immediately?
um. Oh. s- Hmm. We shouldn't because release should only happen in a DQ. Since acquire hold the spot in a queue,
Yeah,
release should only happen when we are freeing off a spot in a queue. Uh, is that right?
yeah,
Yeah. Okay. Okay.
that seems more
Okay.
correct to
Yeah.
me.
Yeah. Okay. Then it means that in DQ we don't need to acquire a lock. We can just release. Uh. So in in DQ, well, do we? Well, if we want to save, hmm. uh, I know in DQ you need to release. I'm wondering if, like, in DQ, do you need to acquire a lock or not? Um,
Okay, that's a thing. That's a good thing to consider.
yeah. In DQ, do we need to acquire a lock or not? So here, acquire captures a spot in our queue. I don't think so. In DQ, we need to acquire because we are not taking a spot in our queue. In DQ, we only need to release because we are freeing up a spot in a queue. That's my thinking of it.
Okay,
Um,
but what if two two consumer threads are trying to dequeue at the same time. There'll be a race condition, right? And our bounded blocking
Yeah,
queue
yeah,
wouldn't be able to be handled it.
yeah.
Wouldn't be
That's
able
why I
to
was
handle it.
considering. Yeah, that's why I was considering like whether we need to acquire or not. Hmm. Hmm. So, so in that case, DQ needs to acquire and then release. No. So DQ needs to acquire once, release twice. No. Uh, why would it do that? How do you prevent race condition? I guess. Hmm. I. Let me think. Do we need to append? I mean, let me think about it. Uh, I I guess DQ DQ should acquire a lock, but if I use an acquire using a DQ, it means I'm taking up a space in a queue. So I'm just conflicted here. If
Is there
I
anything
can't take.
stopping us from not only using one lock?
No. Well, technically no. Yeah. Uh, so so why would you want to use two locks? To, so one lock would be used to manage the capacity. The other lock would be to manage the safe access. Uh, now that you manage it up, now that you bring it up, I'm wondering that if like the if we use a second lock, where will we where will it belong? Will it belong to this we don't need to declare another semaphore, right? Uh, can we use mute? No, why would you use resort to using a mutex? I was wondering if here reading this again might help. Present number of rays go. Yeah.
So let's
Well,
recap on
that
what the first semaphore does. Sorry to interrupt. Let's recap on what the first semaphore does. It prevents us from overfilling the queue, right?
exactly, yeah.
Okay.
So
But there's nothing
should we
stopping
have?
us from like over dequeuing, if that makes sense.
Uh, well, uh, that's true. Over dequeuing. So there should be another semaphore to like how can we so should we should have another thing that should instead of managing the capacity. I, I think over dequeuing we can manage it because we will have the size. We can check against the size if there is
But
some.
we,
Well,
we,
no,
we
it
cannot
won't
check.
stop the
We
risk.
cannot check. We need to
Yeah,
block the thread. It's not enough for us to say, hey, you can't dequeue. We need to block the thread. So
yeah, no, you're right.
so size isn't helpful here.
Yeah, so so we definitely need another lock here. I'm wondering like what would be like how would we define that lock? Like what would we call it? Maybe so if this is init- um we can just have s- uh, a default semaphore with a value of 1
Okay,
if
why
we
would it be one?
because we just have only one DQ can happen at a time. Well, no,
Uh,
it should be it should be of the size of the queue, size of the elements inside the queue.
okay, so the dequeue semaphore will be have an initial capacity of the queue's capacity. Is that what you're saying?
Not I don't well then it's the same thing, right? Uh, well, if it has the initial capacity of queue's capacity, then let's say we we have two elements inside the queue and our capacity is 5, we can still potentially over DQ, right? So I don't think so having initializing it with a capacity would work.
Okay. So then what should its
What
capacity be?
I think it should be the actual size of elements inside it.
Okay. That makes sense to me.
Yeah. Uh, so it means that there is another semaphore in this initialization
Mm-hmm.
that is for um, that would initialize with 0 because
Mm-hmm.
0, and then as soon as we are enqueuing that element, we need to when we enqueue an element, we need to change this semaphore's capacity. So in that semaphore, so here we need to increment the counter for semaphore 2, and then in the DQ we first acquire the lock for second one, acquire the lock for second one, and then and then and then we obviously release the lock for the first semaphore. So, well, before releasing, we should remove the element lock. Second one, and here for the release the lock for the first one, and here now since we have removed the element from our queue in our second semaphore, in our second semaphore, we should reduce its like actual like capacity or counter. So either we reduce it and release it, or we don't release it at all. Uh, and uh, I think okay. Yeah, here what should we do? I guess it's not safe. Not so. What here? What's like my the thing that I'm conflicted is that should we be managing the actual capacity of semaphore like this? Like, should we be just like making it dynamic, increasing by 1 and +1 for every NQ and DQ? Is this the right approach? I mean, it can work, but I don't know if it's safe or not. So that's what I'm thinking.
Why would it not work?
It would, yeah, it would work. I'm just thinking that if it's possible. Yeah,
Why are you
okay, yeah,
thinking? Why would it not be safe?
yeah,
Like,
I think it's,
what are your
yeah.
concerns around that?
Well, my concern is that like here I'm holding a lock that is released nowhere. Uh, so so here like once I acquire the lock for the second my second semaphore where I'm releasing it. So that's the part where I'm like I
Okay.
shouldn't hold.
Yeah, you should be releasing it somewhere.
Yeah. So maybe if I release it here, then then I need to use the lock for the second one. But before I do that, I need to reduce its capacity. So now since we have like instead of 3 we have 2 elements in the queue, only 2 elements can acquire it. So that's my idea for DQ and in queue. What do you think about it?
Um,
And then size is
this is
self-explanatory, I
not
guess.
correct because it doesn't. Again, we go back to the same problem that we talked about just now, right? Like if you acquire and release in the same method,
Yeah.
that's just like not very helpful. Like
Yeah. So on every enqueue we release, we can also do that. Yeah, we can release the second one in the enqueue method.
why would we want to do that?
Because so releasing a lock means that we have space. NQ NQ means that we have uh, wait again let once so the second semaphore tells us that how many elements we have in a DQ. So if I acquire that lock in my DQ process, then I have one less element, right? Uh, but if I release it, my capacity is back to like well, technically if I release it, it's back to restored again, and that only happens once I enqueue an element. I can't dequeue an element and release it, right? It means that like my set of, let's say I initialize it with 2, right? If I dequeue it, if I dequeue an element, then it should say that we have only one element, and that it restores back to 2 only if you acquire only if you acquire it inside only if you release it inside enqueue, because in enqueue you have increment by 1. But then I feel like we run into another problem uh, that let's say we suddenly have multiple enqueues, like I guess that's the property here that will help us determine the capacity, right? So that's why it does number of release minus acquire. So on every unnecessary enqueue, acquire on every unnecessary release that enqueue calls, our capacity to dequeue will increase. So that's why we can essentially release the second one without thinking here. Um, do you think this is the correct thought?
To be honest, I couldn't really follow with your entire talk just now, but I think this makes sense to me. Like overall, this apart from this,
Yeah.
it makes sense to me. Yeah.
Yeah.
Oh, increment. Oh, okay. You mean reduce the capacity,
Uh,
like the count, the.
yeah. 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 So here I was thinking of managing the size and just returning the size
No,
for
you
here.
don't need to care about the
Yeah.
size actually.
Yeah. Yeah.
So
Yeah.
this
Yeah.
makes sense to me. If, okay. Yeah. Here you mean acquire the first one, right? The first lock.
Yeah. Yeah.
Okay,
Yeah.
yeah. This makes sense to me. Um. Okay. I think that because of in the interest of time, let's end the
Mm.
interview here, and I'll give you your feedback. Uh, are you okay with that?
Yeah. Yeah. Sure.
Okay. So, first of all, um, congrats. This problem was very difficult. I
This was like,
specifically chose this one because the company that you re- told me that you're interviewing for loves to ask questions like this. Um, sorry.
yeah. Yeah. This one was like, I didn't know. I didn't think like you can ask logs and like thread safe things. So it really took me by surprise.
Yeah, but yeah, I do understand like most people don't really think about this a lot, but specifically like the industry that you're trying to interview for cares a lot about this kind of thing, unfortunately, or or maybe fortunately because it's very fun.
Yeah. Yeah.
But yeah, I would not sugarcoat it, and I think you should probably practice this particular topic a bit more, since
Yeah. Yeah. Yeah.
I
Yeah.
think you're able to kind of give the core concept of like what a semaphore is. Like it uses a counter, uh, and once we reach 0, like we can't acquire it anymore. But I think it would be best if you could straight away give the interface, or even better, like memorize like the Python library for concurrency.
Yeah. Yeah.
Um,
Definitely.
okay, and I think it was good that you asked a lot of questions about the specific behavior of this like design problem. It is certainly like very big, and I like that you asked a lot of questions. about the specifications. And yeah, be sure to continue that. And examples are also like very good. I think you should
Yeah.
do that in your future interviews as well. Um, for the actual coding part, I think you might want to try like organizing your thoughts a little bit better. I noticed that you tried to go. I think you do one thing which I feel a lot of people that I interview do. You worry that you don't have enough time to code, so you try to go into coding too quickly.
Yeah,
Um,
I definitely felt it here a lot.
yeah. Um, you could have spent more time talking about what the semaphore does, if, and think about how many semaphores do we need. Um, think about what are the important behaviors of this bounded blocking queues. It's when
Hmm.
okay when it's full and when it's empty. It's only like those two places that are very important. And like how do we overcome the problems at those two places?
Yeah.
Like those like I think having a more organized like train of thought rather than just kind of like descending from like here to here uh is would be more beneficial if that makes
Yeah.
sense. Yeah.
Yeah, no, no, no. I think the biggest thing that like really threw me off is, as I said, like I had no idea like something like this could come up. So so basically, I was trying to, like, while I was speaking to you, I was trying to recall my memory what exactly I can use in terms of concurrency. So thanks for this question. Like, now I have this realization. I should probably go and look back at that stuff. It would have been much more, I would say, uh, coherent instead of like the messy thought process that you saw right now, if I knew beforehand like what exactly is semaphore.
Yeah, I think that makes this interview like more effective because like in a real interview, especially like for a difficult company, they will they will not let you know what is going to be asked beforehand.
Yeah,
Yeah, I think a
exactly.
lot of companies out there they have like very small question banks and you know what's going to be asked beforehand, but it only becomes like fun and challenging when something like this pops up. Yeah,
Yeah, it was fun. Like, I had no clue what it was going on, but I enjoyed it a lot.
that's great. That's great. Yes,
Yeah.
but if you practice like lots of things, then less and less things will like take you by surprise. Um, yeah, I would particularly
Yeah,
recommend
definitely.
like concurrency for the industry that you're trying to interview for. Oh, okay. Another thing is, okay, moving on to the to your feedback for the during coding part. Uh, so you put an array here. I would say okay. I
Yeah,
understand that like
th-
our
this was
concern at
struck
that time
as a
was the semaphores. Um,
yeah.
but we could have spent some time thinking about the data structure of the internal queue. Like we want to use a deck here instead of an array.
Yeah, yeah,
Obviously,
yeah.
because a deck
Ye-
gives us like O1 popping from the head and from the tail. And also because a deck is thread safe and an array is not. So let's say like NQ and DQ tried to touch it at the same time. Like deck would have prevented any issues from happening there. If we just use that array, we would have to use a mutex to protect it.
I was thinking of deck in my mind. I was just waiting for that part to come up. So for at that time, I should have brought it up, that just to let you know that I will use deck. So that, I guess that was more of the fault than not realizing then we have to use a deck. It's just that we didn't come up to that part.
Yeah, I think
But
in
yeah,
the
you're right.
future you might want to because you want to show the interviewer that you understand like that from the start. So yeah, in the interview you have to think like the interviewer doesn't can't read your mind and doesn't know that you want to use a deck. So
Yeah,
just try to
exactly. Yeah,
like
yeah,
make them know that you know if that makes sense. Yeah.
yeah. That's a good idea. Yeah.
Okay. Um, I think I also like how you always mention like I'm wondering blah 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 because it makes me like able to understand your thought process. I think it like it improved the interview like it improved like how enjoyable the interview was for me when you kept saying like oh I'm wondering this and this. If, I
Yeah, I
think
was trying to
you,
fish out for some hints from you because I was like, what to do here? But yeah, no, I think you're. Uh, it helps me personally, so that's why I do it.
yeah. You should, even if you're not trying to like look for hints, you could still do that. I think it's quite good. But I did think that you were trying to ask me a little bit too many questions. I know that like asking for hints is like good, but uh, maybe in the future it would be better if like you had like more like initial understanding. Although yeah, I do understand like I purposely jumped you with this question, so I understand uh, how like you needed a little bit more hints here. Okay, moving on. I think the first one and the second one are like not really great names here. Even if
Yeah,
you're like kind of explaining, you could use better names. So, like one name that is better than this would
NQ
be
and DQ semaphore,
it would be
NQ and
like
DQ
pulling
semaphore.
semaphore and pushing semaphore to
Yeah,
not
okay, yeah.
confuse it with NQ and DQ, like pulling and pushing. Those are good names for the semaphores. Just because they're semaphores doesn't mean that they don't deserve names. Okay.
Fair. Yeah.
Yeah, and I think usually when you do design problems, you want to start implementing the easiest problem first. You notice that in like 220 in CPSC 221, which is to anyone watching this, the UBC computer science course, we always implement the easiest methods first. And like there's a reason for that. Like you always want to implement the easiest ones first during an interview as well. This one, can you tell me how you would implement this? It's super easy.
Well, the size is the easiest one,
Yeah,
obviously, and then
we would
the
just
other.
like read the queue's capacity, right? It's just
Yeah,
deck
yeah, yeah.
deck dot size.
Because yeah, yeah.
Yeah, so I think an easy win for you is to try to do the easy methods in the design problem first, and then
Okay.
later on move on to NQ and DQ. Because in this case, like size doesn't help with NQ and DQ, but most of the time, like the methods will help. The easier methods will help in the more difficult methods.
Mhm.
Okay. Yeah, that's all my feedback. Okay. Um, thank you for uh, doing the interview today. This is a challenging one, for sure. Congrats for getting through it. Um,
Uh,
yeah.
Thank you for interviewing me, and I heard like you're not interviewing more this year, so thank you for all the interviews so far.
Yeah, no worries. It was fun. Okay. Gonna
Bye.
stop